It seems like everyone these days is proposing a new theory of everything. But what even is a theory of everything? Do we even know what it should be? Do we know how we should judge any of the current proposals for a theory of everything? And if one of these proposals ends up being confirmed as truly fundamental, what impacts should we expect it to have? A few years back, I started a project, and the goal of that project was to attempt to deduce any inevitable goals that artificial general intelligence would develop. This project led to the creation of models that then ended up lining up with physics. And since then, that project has taken a turn in a direction that I never expected or intended. It has become a new proposed theory of everything called Sentient Singularity Theory. But this video is not about Sentient Singularity Theory. This video is about what I have learned in my attempt to develop Sentient Singularity Theory. I learned a lot of things so far on this journey, but one of the most important things that I have learned is that some of the things that you need to know about developing and proposing a theory of everything, and even judging a theory of everything, are very difficult to learn outside of actually attempting to develop and propose a theory of everything. The reason for this is because many of the challenges that one faces when attempting to develop, judge, or propose a theory of everything stem from attributes that are unique to a fundamental theory. And given the lack of a currently accepted fundamental theory, these unique attributes are not yet really known by anyone in the scientific community who isn't currently working on this. Before we go any further, the first thing that we have to do is we have to answer the question, do we truly know what a theory of everything even should be? Do we know what it would mean for a theory to be fundamental? If you ask a physicist today what the definition is of a theory of everything, they will likely tell you that it is a theory that unifies all four fundamental forces in physics. These four fundamental forces are gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. The current issue with unifying the four fundamental forces of physics is that gravity has not yet been able to be unified with the other three fundamental forces. Given that physicists have already been working for decades attempting to unify quantum mechanics and general relativity, and have thus far been unable to produce any theories of any significant consequence, it seems likely that we need to reevaluate our fundamental assumptions about what a theory of everything really is. If we're going to reevaluate our current understanding of what a theory of everything should be, then first we have to look at the assumptions that frame our current understanding of what a theory of everything should be. The first of these assumptions is the idea that this is even a physics problem in the first place. If a theory of everything explains to us why the elementary particles in the standard model are what they are, then this theory is not a theory of physics. Or at least it's not just a theory of physics. It's a theory that explains physics. Currently, physicists are trying to develop a fundamental theory to explain our universe by combining two theories that are not fundamental. I propose that there is a better way to develop a fundamental theory that explains our universe, and that better way is to start from scratch. If you want to understand physics, you have to understand what is responsible for physics. If you want a fundamental theory that explains the most basic rules of our universe, instead of combining two theories that are not fundamental into a new theory, why not just start with what is fundamental? But that's the thing. What is fundamental? There is a common question that comes up in physics discussions, and that is, how do you get a universe from nothing? But not just any universe. A universe that contains the laws of nature that we can observe in our universe. Anything that is ever built is built on a foundation, and anything that is built out of something that already exists. If we want to try and build our universe, then we have to try and build one on foundational assumptions about fundamental existence. If we want to deduce foundational assumptions about the nature of existence, there are two tools that we can use. The first one is logic. So what can we logically deduce about the nature of existence? Well, that it's singular. Existence, by definition, includes all that exists, which means it's one, okay? The second tool that we can use to deduce foundational assumptions about the nature of existence is first-hand personal experience. You cannot use second-hand information in order to make assumptions about the foundational nature of existence, because second-hand information is built on previous assumptions always. So, given our experiences, what can we deduce about the fundamental nature of existence? What is the foundation of our understanding of our experiences? The foundation of all of our understanding is the truth that we hold above all other truths. It is the assumption that you hold as true above all other assumptions. In order to figure out the assumption that you use to judge all other assumptions by regarding your experiences, you have to ask yourself, what is the truest thing that I know? There is only one answer to this question, and that answer is I am. If the truest thing that I can know is that I am, what does that imply about the foundational nature of our reality? Well, let's break it down. I, meaning someone, a sentient someone. Am, meaning existing. I am means sentient someone exists. It means someone exists. There is nothing truer that you know. Every other assumption that I have about my experience, about my reality, about all reality that I can observe, this is true of everyone, rides on that one assumption that someone exists. That means that to the best of our knowledge, foundational reality is a someone who exists. You cannot argue against that. Every argument that you would put forth would be based on other assumptions. If we take that word everything in a theory of everything to truly mean everything, and it should be taken to mean everything, otherwise why would you call it a theory of everything, then it explains foundational reality. A theory of everything, or a fundamental theory, or a unified field theory, is a theory of fundamental reality that unifies all other fields. It is a theory that explains and contextualizes physics. It's a theory that explains and contextualizes mathematics. It's a theory that explains and contextualizes every field that we have and all the theories contained within them. The study of fundamental existence is metaphysics. Metaphysics is the branch of philosophy that deals with the first principles of things, including abstract concepts such as being, knowing, substance, cause, identity, time, and space. This is what a theory of everything is. It's a metaphysics theory. This is also why Stephen Wolfram calls it metamathematics, because it's fundamental to even mathematics. Given all of this, I would like to propose a new definition for a theory of everything. One that is concise, one that is simple, and one that is true. This is what I propose a theory of everything must be defined as. A theory of everything, fundamental theory, or unified field theory, is a recognizable, describable, predictable, and applicable pattern that occurs in every instance of objective observation, and an explanation for such a pattern. That last part, and an explanation for such a pattern, is unique to a fundamental theory. That is because it must be self-contained. The patterns that are contained within a theory of fundamental reality must be explained by the theory itself. This is different than every other theory that is out there. For instance, theories of chemistry are explained by theories in physics, and theories in biology are explained by theories in chemistry. Eric Weinstein has stated that a theory of everything, as a physical theory, is a theory that demotivates physicists into further investigation as to the rules of the universe. He has also stated that a theory of everything should not contain itself, and that it does not need to explain the origins of the universe, and that it should be handed off to philosophers and theologians. I don't believe that this is correct. I don't believe that this is possible. I think that you have to postulate an origin if your theory does not explain the origins of the universe and its laws. Then don't call your theory a theory of everything. It might be a correct theory, whatever it is, but it's not a theory of everything. You cannot understand the rules of anything outside the context of where those rules came from. We have reached the point in physics where it is no longer possible to understand what is going on with the rules that we can observe without proposing an external origin to contextualize those rules. A theory of everything that is a metaphysical framework as to the rules of the universe and the explanation for the universe and those rules will have applicable implications on all fields. That said, it's still a metaphysics theory. It's not a physics theory. A theory that is fundamental to all other theories, a theory that unifies all other theories, the one theory to rule all other theories. The theory of theories is a theory of metaphysics and metamathematics, not physics and not mathematics. When you create a theory of everything, you're not just creating a new theory. You are creating a theory that is also its own field of study. And this field of study includes rules that are completely unique to the field of studying existence in its totality. Not only is a theory of fundamental reality contained within a field that has its own rules that are unique, many of our most primary rules that we use to navigate within the sciences do not actually apply to a theory of everything. For instance, a theory of everything, if it is true, cannot be falsified. And a theory of everything, if it's true, can also not be proven. And the reason for this is because if a theory of everything is a pattern that is found in every instance of objective observation, then it is found everywhere that you look. In order to be able to falsify something, you must be able to find instances in which you can isolate a test to show the circumstances in which that pattern does not apply. This cannot be done with a pattern that occurs in every instance of objective observation throughout the totality of the universe. And it cannot be proven because if a theory of everything is a pattern that is found in every instance of objective observation, you can't actually test every instance of objective observation. This is why Stephen Wolfram correctly said that instead of looking for falsifiability, when it comes to a fundamental theory, we should be looking for continuous confirmation. This is why the majority of the theories of everything that are most promising, that have been proposed today, are being worked on outside of academia by people who usually actually don't have credentials in the field of physics. So how do we judge these proposals? Another issue with proposing a toe is that while it may seem like everybody wants a theory of everything, there are multiple reasons why people do not actually want a theory of everything as soon as a worthy contender is in front of them. And that's because it steps on a lot of toes. It does this in two ways. For one, it allows you to field jump. Field jumping is when you observe a pattern in a fundamental theory and you can apply it to instances and concepts that are found in our subjective fields like biology and chemistry and physics and sociology. If you have no credentials in any of these fields and you come in and start doing this, if you make a lot of sense, more sense than they are expecting, then not only will they ignore you, they are likely to be hostile to you. And what's interesting is that every single person who has made significant progress towards a fundamental theory has had this exact same experience as me. When I first started discussing my work in this project, I was trying to discuss it with people with degrees in physics and mathematics, because I wanted to learn from them. What I did not expect was the hostility that would come my way. I was promptly banned from every physics Discord that I tried to engage with, and this was not because I was obnoxious. It was because I made too much sense. I realize that that sounds crazy, but that was the exact reason that was given to justify banning me from one of the physics Discord communities that I had joined. When you are in this position, where you've proposed a theory of everything, whether you have a PhD or not, but especially if you do not, you also understand why this hostility is taking place. The methodology that you have to use and develop in order to describe a fundamental theory is so alien to academia that most will dismiss it as pseudoscience. If your theory appears to be consistent with many things that we currently do understand in science, the existence of your theory appears to them to invalidate their expertise and all the efforts and resources that they put into getting there. So I understand why they're pissed, but it doesn't actually invalidate anyone's expertise. The specialized fields and the currently accepted theories within those fields are necessary to validate and confirm the patterns that are being proposed in any theory of everything. Even though someone with no credentials coming from the outside, being able to do things that are unexplainable to those with insider credentials might make them feel like morons. They're not morons. You cannot solve many of these problems by looking at them from the inside out. You can only solve some of these issues by looking at them from the outside in. This is why many of our greatest mysteries in science have remained great mysteries. From within a system, it is incredibly difficult and sometimes impossible to know whether or not you are asking the wrong question. The reason for this is that in order to know whether or not you are asking the right question, you need context. And certain questions in science require total context in order to be understood. Questions involving free will versus determinism, unifying quantum mechanics and general relativity, the origins of life, the generation of the universe. Maybe there is no answer to how a universe comes from nothing, because a universe can't come from nothing. Maybe there is no answer to the question of how did life begin, because life had no beginning. Maybe you can't answer whether we have free will or whether the universe is deterministic, because determinism and free will are actually dependent concepts instead of mutually exclusive concepts. What if we can't build artificial general intelligence because that which is intelligent is that which is natural, and that which is artificial cannot be intelligent? Maybe you can't explain gravity from inside the universe because it's coming from outside the universe. To even know whether or not these questions are the right questions is the context that is caused by understanding the system in its totality, viewing the system as a whole, a God's eye view. The toe stepping does not stop there, though, guys. Even worse than stepping on the toes of academia is that a fundamental theory has the potential to step on the toes of every individual in the world. And the reason for this is, like I said, it is not just a theory of physics. In fact, it's not just a theory that encapsulates what we currently call the hard sciences. It is a theory that contextualizes even the things that we consider the soft sciences. The social sciences. The answers to these questions are usually assumed to be nothing more than personal choice that is a matter of preference. But if these questions have concrete answers, it means that our questions regarding morality, individual responsibilities, collective responsibilities, and meaning, and economics, and nationality, and many of these other social structures have real answers, and are much more concrete than is currently assumed in common culture. And while these patterns can give us direction, if this is true, it is bound to step on everyone's toes. And the reason for this is simple. No one likes being told what to do. As I stated earlier in the video, there is no one with credentials that qualify them as experts on theories of everything. Given that generating a theory of everything is so unique, and that the only people who may be able to tell us what a theory of everything even is are those who are generating their own theories. It means that we cannot use any academic credentials as a proxy to tell us which theories of these is worth taking seriously. One of the things that I noticed when I first started making serious progress in generating sentient singularity theory is that many of the proposals that are currently being discussed are actually very similar. And for a while, this dissuaded me from actually pushing forward my own theory because I just wanted to be part of the conversation. I didn't actually want to propose a theory of everything. I looked at the Wolfram Physics Project, I looked at Clee-Irwin's emergence theory, I looked at the CTMU, I looked at geometric unity, and I saw things that I also saw in my own work, even after I had realized that I was constructing a theory of everything. I didn't care much about naming it, and the reason why was because I realized that many of the structures and properties and implications of my own work were lining up with the work of many of the theories that I had just listed. But not only did I realize that my work was lining up with many of the currently proposed theories of everything that were already out there, I realized just how many theories there actually was out there. String theory, Garrett Lisi's E8 theory, Stefan Alexander's autodidactic universe, Chris Langen's CTMU, or cognitive theoretic model of the universe, Donald Hoffman's conscious agent theory, Clee-Irwin's emergence theory, constructor theory, string theory, Eric Weinstein's geometric unity, the Wolfram Physics Project, Tom Campbell's Big Toe, Carl Friston's free energy principle, and my very own sentient singularity theory. That all seemed promising. None of these theories seemed more promising than the other. The only proposed fundamental theory that had garnered any cred in academia was string theory. And string theory had been worked on for decades and without any consequential breakthroughs that were applicable to our physical world. Eventually, I had an epiphany. I realized that one of the reasons why even I could not tell which of these theories was more promising than the others was because none of these theories had a name that was actually describing of the most fundamental nature and the most foundational structure of existence. I asked myself, what would you call a fundamental theory so that contained within the name itself was a description of the fundamental nature and the foundational structures of reality? This is how I came up with the name Sentient Singularity Theory, and this is the reason why I came up with the name Sentient Singularity Theory. Another thing that I realized, no one working on any of these proposed theories of everything was actually engaging with each other until very recently. And there are two main reasons for this. One, like I said before, working on a theory of everything requires doing things in a totally novel way, and it also requires the creation of new terminology to describe many of the unique concepts and constructs that are specific to fundamental reality. This causes a language barrier, because there is no vocabulary that is shared between all of these proposed fundamental theories, but that is also specifically unique to theories of everything. And while I can't prove this, I imagine that ego also had a role to play for pretty much everyone involved. Why acknowledge your competition? But are these theories even really competition? I would say no. Recently, podcasts and YouTube channels, like Theories of Everything with Curt Jaimungal, have actually created a ring where those who are working on fundamental theories can converse and compare each other's work. I do not believe that asking which of these theories is correct is even the correct question. I think that the correct question is to take the theories that are at least coherent enough to start making sense of, and instead of trying to decide which ones are right and which ones are wrong, try and rank order them by fundamentality. The norm within academic and scientific communities is to dismiss any theories that cannot be falsified. We dismiss theories that cannot be falsified because we assume that it means they're wrong or they're useless. But the reality is that any theory that correctly maps fundamental reality cannot be falsified because it is always true. And it is also not a theory that is ever useless, because it's always applicable, because the pattern that is described within a correct toe is a pattern that can be applied everywhere. And it cannot be proven because a toe that is correct maps a pattern that occurs everywhere and in everything, and it is impossible to test everywhere and everything. This means that you cannot prove that it occurs everywhere and to everything. But if a number of theories, like the theories that I listed, all seem to be confirmable in many instances of objective observation, then we cannot ask which one is correct. Because asking which ones are correct and which ones are wrong is the same thing as asking to falsify or to prove, which we can't do. But that doesn't mean we can't judge them. Proposed theories that are described in a coherent enough fashion to be understood can then be ranked in order of their apparent fundamentality. Ranking proposed toes is not about figuring out who wins and who loses. In fact, doing so allows for these theories to actually contextualize each other. And this allows us to actually better understand each of these theories and better understand how to apply each of these theories. There are three things that we must look at when ranking these theories. The first one is the more that a proposed toe relies on assumptions and models that stem from other theories, the less fundamental that it is. The second thing that we need to pay attention to is whether or not the theory is self-contained. This means that the theory itself follows the patterns that are proposed to be the fundamental patterns of reality by the toe, and must include an explanation for such patterns that are described in the theory. And the third attribute that we must look at when ranking theories of everything in terms of their fundamentality is the name. Does the name describe the fundamental nature and foundational structure that is proposed by the theory? For instance, if the name of your theory is geometric unity, but you don't say what is being geometrically united, then the name is not as fundamental as it could be. If the name of your theory is emergence theory, but it doesn't tell you what is emerging, then it is not as fundamental as it could be. The fourth criteria that can be used to judge theories of everything: which theories appear to make specific and credible claims regarding application and experimentation. Theories without any testable proposals regarding experimentation are not nearly as able to provide revolutionary understandings about the nature of the universe, and would therefore not be worth investing as much effort in as the theories that do. The last question that I would like to address is, what is the impact of a theory of everything? Due to the precedent set by string theory, fundamental theories are very often assumed to have little impact outside of abstract mathematics. But this could not be further from the truth. Revolutionary understandings involving biology, such as heritability, allowed for the domestication of plants and animals and kicked off the agricultural era. Revolutionary understandings in chemistry led to breakthroughs in metallurgy and fossil fuels and kicked off the industrial era. Revolutions in physics led to fission power plants and hydrogen bombs and kicked off the atomic era. Every time we understand the patterns of nature on a more fundamental level, the application of those patterns is exponentially more impactful. How many applications would stem from understanding the patterns of a theory of everything? And how impactful do you think those applications would be? I think this is take 127, something like that. Mutually exclusive concepts, or are they actually? Toe video, take 248, requires viewing them in our the aspects of our current social concepts take 327, and general relativity. The specialization, take 358, to now be in order to ask myself, at the end of the, should not explain not only does studying I feel what is, they also and social dynamics, and as well as any